Trigonometry, Chapter 1, Trigonometric Functions, Section 1, Angles, Video 8, Analyzing Revolutions and Angular Velocity. This series is based on content from Pearson's 12th edition by Lial, Hornsby, Schneider, and Daniels. In this video, we'll look at an example involving angles, revolutions, and angular velocity. Angular velocity measures a rotational measure, such as degrees or revolutions, over a fixed time interval, such as per second or per minute. For example, the tachometer on a car dashboard measures RPMs, revolutions per minute, of the engine's crankshaft. Should be an apostrophe on engines, but we'll let it slide. For example, the tachometer on this car dashboard, the bottom left, measures RPMs, revolutions per minute, of the engine's crankshaft. And it should be noted that most tachometers, TAC for short, measure it in thousands of revolutions per minute. This car's crankshaft, the needle's pointing at 3, which means 3,000 revolutions per minute. That's pretty fast. That's 50 revolutions per second. So when you rev up your engine and you see this needle go up here, your crankshaft is rotating really fast, sometimes too fast. Another example of angular velocity is the internal disk drive in a computer, which is literally a spinning disk. Suppose the disk drive rotates at an angular velocity of 480 RPMs, revolutions per minute. Through how many degrees will the disk rotate in 3 seconds? Well, first we got to determine how many revolutions the disk makes in 1 second. Since it makes 480 revolutions in 1 minute, and there are 60 seconds in a minute, we divide by 60 to see how many revolutions in 1 second. 480 divided by 60 is 8 revolutions per second. Now we convert to degrees. We multiply by 360 since 1 revolution is 360 degrees. 8 times 360 is 2,880 degrees per second. Now we know degrees rotated in 1 second, multiply by 3 to get the degrees rotated in 3 seconds, plural. 2,880 times 3 equals 8,640 degrees in 3 seconds. The disk rotates 8,640 degrees in 3 seconds. Now, this solution involves multiplication and division at various times, as you can see here. As such, it's sometimes tricky to decide whether we should multiply or divide at any step in the process. A more organized way to convert units is called unit analysis or dimensional analysis. And again, bad grammar here. That's driving me nuts. This process involves setting up the product of fractions designed to cancel the starting units and end with the desired units. Watch. In this example, we're starting with 480 revolutions per minute and want to end with just degrees in 3 seconds. So we're going to start with 480 revolutions per minute as a fraction. 480 revolutions on top of 1 minute. Now we're going to multiply by fractions that will cancel current units and introduce desired units. Let's start with minutes. Since we're being asked about the degrees rotated in 3 seconds, we want to set up a fraction using minutes and seconds. Because we want to cancel the minutes, we need a fraction with minutes in the numerator and seconds in the denominator like this. This way, when we multiply, the minutes will cancel. Any matching units in the numerator and denominator can cancel. Since 1 minute equals 60 seconds, we set up this fraction of equivalent units of measurement, 1 minute over 60 seconds. Next, we want to cancel revolutions and introduce degrees, because we want to know the number of degrees in 3 seconds. Since 1 revolution equals 360 degrees, we next multiply by this fraction. 360 degrees over 1 revolution. Notice we put revolutions in the denominator to cancel the pre-existing revolutions in the numerator. All the highlighted units will cancel. So far, we're left with degrees per second, degrees on top, seconds on the bottom. Now multiply by 3 seconds. Now that's not a fraction, but the seconds will cancel because any non-fraction can be put over 1, and the seconds will cancel. The only unit of measurement left is degrees, which is the unit we want in our final answer. Now that we got it set up, all we have to do after canceling all the other units is from left to right, multiply by numerators and divide by denominators. You can ignore ones since multiplying or dividing by 1 doesn't change anything. So from left to right, we would do 450 divided by 60 times 360 times 3, which gives us the correct answer. And I know it seems like a long approach, but I promise you, it helps you organize when to multiply and divide, and this skill can be used in other courses such as physics and chemistry when you're converting units of measurement. Now you try. Pause the video and try the following problem. In the late 1960s, records were first produced so that music fans could purchase individual songs instead of entire albums. These smaller records had an angular velocity of 45 RPMs, rotations or revolutions per minute. How many degrees did such an album rotate in 2 seconds? Pause the video and give it a try. And here's your spoiler alert. I'm about to show you the solution. So if you haven't paused the video to try it, now is your last chance. Solution in 3, 2, 1.